Welcome to the second half of Simplilearn's Python tutorial. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. We're going to take on 7 parts or 7 code challenges that you can do to take all the basics we've covered so far in Python and see how to apply them. And we'll start with part 1. Part 1, we want to go ahead and see if we can print the number of occurrences of each character in a string. And this would be a good time to pause the video so you can actually try to solve it on your own before we go ahead and give you the solution we came up with. Now remember, there's always multiple solutions to any of these challenges. So if you come up with a different one, that's great. It just means you're thinking on there. The first thing we want to do is we want to go ahead and get an input. So we want to go ahead and pull up an input for our word that we're going to type in. And then we're looking for the number of characters in a string. So we need some way to track it. And we have what we call a dictionary. Now if you remember, we briefly touched upon the dictionary. A dictionary is denoted with 2 brackets. And it comes in the form of a key. So you'll have your key code. And then that key code is set to a value. So the value can change, the key code cannot. And if we had brackets around this, could initiate it if you already know your initial keys and values with something that looks like this. And we can also, here's our D, assign them as we go. And so we'd have our key, and then this would equal our value. And what's nice about these 2 setups is that we have a key code which could represent our characters, and then we have the value which is going to represent the count. Hopefully you remember map reduce. We're thinking map and reduce. This is such a common question that comes up in map and reduce. So we're going to map all our characters out and then count them and reduce that to, in a huge map reduce program, you would actually do each document have a summation, and then that would be sent and brought together and then reduced to just a single representation of it. So we're doing kind of the end part where we're just reducing this word. So here we have our dictionary, and then we want to go ahead and do a for I loop. For I in S. So our input is S, and this will iterate over each character in the string. And the next thing we want to know is, do we already have D in our dictionary? In this case, we're looking at each of our I's. So if I in D. So if it's already in there, then we can simply do this. We can simply do D of I. And then you can do the plus equals, and then of course we're just adding 1 to it because we're incrementing it by 1. Now if it doesn't exist in the dictionary and you try to do that, you'll get an error. It'll say no key value there. So now we have to do a thing where if I is not in D, we do simply D of I, and we initialize it with 1. Keep it simple. And then finally, we've got all our different things. We can just print D. And if I run this, let's go ahead and take that and run it. Comes up, says enter a string, and we'll do hello. I'll hit enter, and you'll see I have H, capital H equals 1, lowercase e equals 1, L equals 2, there's 2 L's, and O equals 1. You can also, if you're trying to look at it a little bit clearer, you could do for key in D, we could do something like this. Print D of key, and you got to remember it doesn't actually print the key unless you tell it to. So here's the key and the D of key. So I can also do it this way. See if we can pick a better word on here. You need to actually do a full phrase in here. So welcome to Python. And hit enter, and you'll see that we have W1, E has 2, L has 1, C1, O3, M1, there's 2 spaces, T is 2, P is 1, Y is 1, H, and so on. So this is a very simple set of loops, but it covers a lot of interesting key points that you'll use throughout any kind of big data or map and reduce program. So let's move to part 2 or challenge 2. Let me just clear my palette so we have a nice palette. And what we're going to do for part 2 is we're going to insert an element at the kth position of a list. And again, pause it if you need to. Let's go ahead and create our list. And in this case, we're going to do just a standard list. We'll do some mixed elements. We'll have like 23. It looks like they sent me an example of the list. Let me just grab that. So let's do 23. Hey, 89 Python. So we have a nice list there with 1, 2, 3, 4, 5 objects, or 0 through 4 if you're thinking indexing. And let's go ahead and do this. Let's just print the original list, comma list. And then we need our input, n equals input, and I guess we need to put where we're going to enter it at. So it says input, and let's do enter an index between, let's see, we can do this a couple different ways, but let's say we do 0, which would put it at the beginning, and then at the end. How would you get to know the end? Well, we could do this, plus string of length, in this case length of list. And remember, we don't want it to type in the actual, well, I guess it could type in the actual end. So it could be 0 or it could be the very end of the list. So this end should give us a nice input. And then let's have an object, or we'll just call it K. And actually, let's put this above. Sometimes it's nice to put these in a different order. K equals input. Let's go ahead and have it enter an element. And so this will automatically be a string that we enter here. I'm going to go ahead and just add a space there so it stays on the same line. If you have a larger screen, this might look better if it goes down a line. But in this case, I want to go ahead and just keep that in the same line. And we'll do this on here. I'll do plus and add a space. And this will be our element N and K for the actual integer. And we want to make sure this stays as an integer. So let's go ahead and take this whole thing and add integer at the beginning. It's for our index, and an integer at the end. So now we have our input. We're going to add an element. In this case, it's going to always be a string, unless we want to try to convert it. And then we're going to enter in where it's going to go. And so how do we get there? How do we put that in that list? And so there is actually a number of ways. You can actually do an insert. But let's say we don't have the list insert command. Make it a little hard on us. Let's go ahead and do this. Let's go ahead and do a list append. And we're going to append, in this case, K. That's the entity we entered in here. So if we pretend not to do the list insert and we have the append, we can append our value onto the end of our list. And what we're going to do, and again, there's like so many different solutions for this. I mean, if I was just doing an insert into my list, I would just do an insert. But let's say sometimes you have to do, other than finding out the spot on there, you might be comparing the values or doing something else going on. So what we can do is we can go for I in range 0, length of list. So we're going to create an integer that comes in here and just starts at the 0 index, so I for index, and just pages through all of our objects in the list. And what we want to know is if I is greater than, and we had our K value. Now if you did, like I did up here, 0, you could also do K value equals 1. So this gets a little tricky on your input if you're talking about your end client. Do they know to start 0 as place 0, or do they start with place 1? So that might change your coding and how you put this together. Those are things you'd want to think about. And we're going to do temp equals list of I. So we go ahead and we look at our list and we say, okay, I'm going to pull this object off. I'll create a temp here, list of I equals N. And we're going to swap in our N value. And then we'll do N equals temp. So let's take a look at this. I have if I is greater than K, and since we're starting with 0, we'll go do I is greater than or equal to K. That's just because we're starting with a 0 instead of 1. And we go ahead and create a temp variable that goes to that pointer. List of I then equals N. That's our last element. In this case, it's the one we entered. And then we set N equal to temp. So we take this and we take whatever's in that position, we put it in temp, and then we just go all the way through. And what happens is it'll just keep replacing that value all the way to the end. And let's go ahead and see what that looks like. Before we do this, I guess we have to print out an answer. So we'll come down here and we'll go print and our updated list, comma, and this is just list. Let's go ahead and run this. And we'll go down here and let's enter in hello. And I always like to do the extremes. We have 0 and 5. So let's go into 0 and enter. And we have our list, which is original 23 all the way to Python. And now it says hello and puts it right at the beginning. And if you're going to do that, you should also test out the end of the list. So what happens if I put in 5? And then it comes up and you see it puts hello at the end. What happens if we put in 4? Double check. Here we go, 4, and it comes up on place number 4. And I'll do one more test on this, just because I really don't like things going out the door unless I know they work. And we'll put in 1, and you'll see here 0, 1, 2, 3, and so on, and there's our hello. And you can see here we had a nice setup on that. We have our input, and we just go through. It's really important to note that we're iterating through each value, and we're seeing if something important is going to need to change that value. This could be almost anything. This could be that you need to alter, not only insert the value, but maybe increment everything past it with +1 or something. There's all kinds of things that can come up, little weird logic that you wouldn't think of until you start messing with it. Challenge or part 3. Check if the substring is present in a string without using the find method. I remember back in the 90s, this was central to all of your programming, was to do all these little things. Now, of course, they have find built into the functionality. So string, we need to have our input. We're going to input a string, and we're going to input a substring, and we'll call them st for string and sub for substring. And I'm going to jump ahead a little bit here and then come back because we want to look at something. Let's do count equals 0, and then we're going to do our loop for I in range 0. We want to start with position 0, and then we want to go to what? That's where the question comes in. Well, we could do the length of the string. Now there's a problem with this, and that is that the substring might be 5 letters long. So if I go to the length of the string, I'm actually comparing the substring to something that isn't even there. So I'm going past the end of the string that's not really worth doing. So how do we figure out that number? Well, we can do L equals length of our substring. So now we have a value for how long the substring is. And we simply take the 0 to length of string minus L, and then we want to add 1 on there. So remember that this length, it goes exactly to that length without including it. So we have to add the +1 in there to include the very end of that. So 0 to the length of the string. So the next question is, how do we know we have it? Well, if our substring equals string, and we want to start from position I, and we want to go to I plus L, the length of the substring. So if they're equal, we'll print count plus equals 1, our increment of 1, and we'll do print substring. Here's our placeholder, S for a string found at position, and then here's our placeholder for a number, or D in this case. And we'll go ahead and give it just a space off of here. Oh no, that's fine. We don't need a space on that. And then we have our ampersand or percent sign and our tuple. So here's our tuple. We want sub comma I. So that'll put that right in there. This will tell us that it's in there. Each time it finds a substring, we're counting it. And then we print it out that it's part of it. A little redundant because you'll just print out the same thing over and over again. And then we can do if count equals 0. We can print substring not found. And of course an else statement, else print, and we'll do substring, here's our place marker again, S found, another placeholder, D times. And then we can, if you're going to do your placeholders, of course you have to do your tuple at the end, and we have our sub, comma, in this case count. So let's see what that looks like when it runs. Before we do that, let's just walk through it. So let's take a walk through what we just did. So we have for I equals range, we had to kind of fiddle a little bit with the length to make sure we got all the way to the end, but we didn't go past it for finding our sub in the range of the string. Simple if statement says, hey, it's here, count plus equals 1. Let's go ahead and print our substring found. This will be very repetitive, so I don't even really know, wouldn't normally put this in here just to keep printing it. And then it says if count equals 0, we found none, print substring not found. And else, substring s found D times with our count. So let's go ahead and run this. And here it goes. Enter our string. Welcome to Simplilearn. I'm going to hit enter, and we're going to look for the, let's go 2. And it gave me an error. So what happened here? And I, of course, get an error. Hopefully you caught this error when I was putting it together. This should be a colon, not a comma. This is a straight list. So that's why you got to remember what rate you're working in. And it does happen. And we'll go ahead and run this again. And we'll do welcome to Simplilearn. Type in our 2. And it comes up and says substring 2 found 1 times. Substring found at position 8. So now we know what position it's at, and we also have how many times it was found. And since I was just talking about NumPy arrays, let's do challenge or part 4. Find the index for the nth repetition of a number in a NumPy array. So let's go ahead and import our NumPy as NP. You'll see that very standard. And I went ahead and created an array, or our team in the back did. So we are going to go ahead and create our variable AR set to a NumPy array, and it's just 1, 2, 4, 1, 23, 1, 2, 3, 4. So it's kind of a random set of numbers on here. And let's see how we can build this. And at this point, you should be trying to think about how to do it yourself. And let's go ahead, and I'll just paste this in here. We're going to print the original array just so you can double check it in our output. And we're going to do our input. Num equals an integer, and then give a value for the number for your input. So we'll have our num we're going to look for. And let's do this, if num in r. So the first thing we want to know is even is in there. There's always a chance you might not even have that number in there. Initiating or doing initial case. So if we're looking for kind of the base case of do we want to even do anything if it's not in there. So if number in AR. First thing you want to do is check. Otherwise it's not worth processing. And then let's do this. So we want to ask the question, what is the index for the nth repetition? So we got to find out what repetition the user wants. And we'll go ahead and create another input in, give a value for in, which is our repetition or repeat. So give a value for in or the repeat on here. Now at this point, there's so many different ways to solve this. We could iterate through, but we're going to create, and you'll hear the term mask. Let me just type that out for you, where you're masking something. Masking means that we create a series of values. In this case, we're going to create a bunch of ones, and we're going to say it equals np. So here's our NumPy array where our input array equals our number. So this is going to return a NumPy array of either ones or zeros. And then we can actually test it and see what's in there. Now there's other ways. We could just iterate through the NumPy array. Usually when you're working with NumPy arrays, you try not to iterate across them. The whole purpose of the NumPy array is to let it leverage the back-end code so you're not wasting as much resources. And you know what? Let's go ahead and print one out just so you can see what that looks like, what this masking does. So np where r equals number. And let's go ahead and run that. And here's our setup. Let's enter in the number 1 and value for in repeat. It doesn't really matter because we're not doing anything with that yet. We'll put in 3. And if you look at the output of this mask we've created, it's set up and it returns an array, and the array is 0, 3, 5, 9, 15, 18. It returns all the positions of our number in the array. So here's np where r equals number, and then we just called it 1. If you print 1 out, you can see we just get a nice list of indexes, and this is really useful to us. Let's go back in here, and then we can very simply on the indexes do if we have our n, and we'll do less than or equal to the length of our 1. And remember, this is a tuple coming in this array. So we have the first part is the actual indexes, and the second part is our D type. So we really want to do the 1 of 0. And this is important. If you haven't worked with NumPy arrays, or even if you work with them a lot, sometimes you just do a quick printout to find out what it is you're looking at, so you can remember the format on there. And we'll do this if it's less than or equal to the length of 1 of 0. Then we can simply print 1 of our 0 position. And then on here we want to do, since that's also itself as array, we want to do the n minus 1. Because remember, we start with 0. So if we want to find out how many is in there, or what the position it is, we're counting 1, 2, 3, but the array is 0, 1, 2. So we have to put that n minus 1 in there. And of course, if we don't find it, we'll do an else statement, and we'll print there aren't, and then we'll go ahead and put down a placeholder just so we can keep track of it. Occurrences of 1. Just keep it simple this time. And then finally, we'll go back here, and you had our original if number in the R. We of course have an else. Print that it's not in there. Boom. And let's go ahead and run that. And we have our list down here. Let me move this thing back up so we can see what the run looks like. Let's look for 1, and we want it to repeat, have a 4th, and it returns it in position 9. There we go. And if we went up here and entered in, let's enter in just a random number. I don't see the number 33, so we'll put 33 in there. 33 not in the array. So it doesn't even go through because we put that initial test right at the beginning that says, hey, if it's not in here, don't even bother. And then we went through and counted them. Now, you probably found your own solution. Very central to our solution was the where statement, where it's going to map out the indexes of this occurrence where r equals number. And this is part of masking. There's all kinds of ways to mask your data. Usually you mask the whole array across something when you talk about masking. In this case, we're just returning a simple array where it lists the indexes. Let's go ahead and clean our screen here for part 5. Generate a dictionary that contains pairs such as I, I times I, where I integer is between 1 and an entered value. Sometimes I'll break these up if I'm for readability, so we'll do that. There we go. So we're going to generate a dictionary. That's the first thing we need to do. And we need a value entered. So let's go ahead and do both of those. And there's a couple ways to generate a dictionary. Earlier we did the 2 squiggly brackets. You can also just do D equals dictionary. And if I run this, you'll see that it works and asks for a number. Let me go ahead and enter in 4, and it processes. I could have easily just have also done this with double brackets. That's the same thing. So if you see something dictionary, you can also, these are equivalent statements. D equals brackets and D equals dictionary, or the dictionary object. And we'll do for I in range 1 in plus 1. So there's the number we entered. And in our dictionary, we're going to do D of I. There's our key, equals, and our value, I times I. And you could have also done, since this is just squaring it, we could have also done squared. That's the same thing as I times I squared. But we'll go ahead and do I times I, and then we'll simply, because you want to see what your end is print D. And let's go ahead and run this. And we'll shift this up just a little bit. It says enter a number, we'll enter 3, and if I run that, or if I hit enter on there, I get 1, 1, so 1 squared is 1, 2 squared is 4, 3 squared is 9, and you could go on as far as you wanted on there. I could enter in a significantly larger number, but it goes up to whatever my range is on that. This is again an example of dictionary, how to build a dictionary in simple ways on there. Alright, let's go ahead and clear our screen for part 6. Write a program which takes 2 digits, x, y, as input and generates a matrix. The element value in the ith row and the jth column of the array should be I times j. There's a lot of ways to do this. We're going to do this as a list of lists. My first thought though would be to put this in NumPy, because NumPy can do this there's a lot of automated ways to do this in NumPy. But let's go ahead and look at the back end. How would you do this into a regular list? So before we start solving this problem, how do we get our data? We have 2 inputs. What if I wanted to have just one input, where I have you enter x, comma, y? What would that look like? Take out the space there because that could cause an issue. Well, there's a couple ways to do this. One is if we want to generate an xy, this member is going to return a tuple for whatever I do. We could do something like this. So on here, we're entering a string with 2 integers. How do we convert those? Well, we can do integer x for x in string.split. This is a really kind of a fun shorthand for Python for iterating through our setup. So what we got here is we're going to first of all split our string. So here's our string. It comes in with 2, 3, and then we take and we split it by the comma. And for each entity in that split, we want to return the integer of that entity. In this case, we've labeled it x. And so this should go through and do x, y, and it should return an x integer and a y integer. And let's just see what that looks like. Let me just go ahead and print x, comma, y. And let's go ahead and run that. And here our xy is, we go 3, 2, hit enter, and it enters 3, 2. Now, if you're putting out a full package, what happens if you have somebody who's overzealous and does something like this? 345, 3, enter. We're going to get it unpacked too many values. So this returned this huge list of numbers I typed in and gave me an error. So you got to remember that when you're doing these different inputs, you might sort it out and just look for the first 2 of them. There's all kinds of different ways to do this. So now we have our xy. If you went ahead and just did the enter x and enter y, that's okay. And we want to generate a list. So our list that we're going to put together is going to be, and again we're doing some nested stuff here, which is a lot of fun. We're going to create a 2 by 2 matrix, and so we're going to have for 0 for column in range y and for row in range x. So what we're doing here is this is going to put a 0 in each of these in here, and then this is simply column is R for column. Column is nothing more than a placeholder. I could have done for C in range Y. Same thing with row. That's because it has to have a value that shows up here. And we're just going to fill everything with 0. And let's go ahead and print this. Print list. We run this, and you'll see here's our enter xy. We'll do 3, 3, and we end up with 0, 0, 0, 0, 0, 0, 0, 0, 0. Here's our 2 iterations done the Pythonian way. It's going to return, you have the square brackets on the end, so it's returning an array. And for the first one, we're going to put 0 for column in range of y, and then we're going to repeat that again for row in range of x. Instead of 0, we can simply do this. I can do column times row. And if we run this, we'll see here's our xy. Let's do 3, 3 again. That way it's not too big on there. And we end up with 0, 0, 0, 0, 1, 2, 0, 2, 4. And we might get a little fancy in this and do, oh, you know what? Let's do it this way. Import NumPy as np, and then maybe we'll do NumPy array equals np.array of and then we'll enter in our list that we created, and then let's print NPA. Remember that when I see here matrix, I automatically go right in for the NumPy array. So we'll enter our 3, 3, and you can see here that NumPy is designed for doing matrices. And so we have 0 times 0, 0 times 1, 0 times 2, 1 times 0, 1 times 1, 1 times 2, and so on. So we create a nice little matrix of I to j. And then we put it into NumPy just because we can. And NumPy has such a nicer format on there. So let's go ahead and clear our palette. Let's move on to part 7. And in part 7, we're going to find the HCF of a two numbers using recursion. And HCF, if you don't know what HCF is, it's highest common factor or denominator of two numbers using recursion. I couldn't remember it. I had to look that up. So let's do a definition. We'll create our little function, HCF. And what comes into there is going to be x and y. And what I want to know is we want the highest one, so we'll do if, first of all, y is not equal to 0. If it's equal to 0, you don't want to divide it anything because they'll give you an error, anything divided by 0. And let's take that and we're going to just return HCF of y comma x, and here's a remainder of y. So HCF y of x of remainder of y. So we're looking for, this is just the remainder, so it's going to return the remainder on here on this. Else, we want to return x. And so we need our input on this before we go any further. So let's grab a input, and we'll do the same kind of input we did before. We're entering x and y, enter two positive integers. And this is just from a previous example. So we'll just go ahead and grab the integer x for x. And in this case, it's not string. Keep it the string on there, st, and have our two integers here from before. Keep it simple. And then let's just go ahead and combine it all into one line. Pythonian way. If you can put it into one easy to read line, then you should do so. So we're going to print HCFF of placeholder D, and placeholder D is placeholder D. And this is our x, our y, and then we're going to just print out the return value of our HCF of x, y. Now let's go ahead and run this. We're going to enter in two positive numbers. Let's go 12 and 18. And so the HCF of 12 and 18 is 6. That would be our most common denominator. Let's go ahead and clear out part 7, and then bonus. We are going to throw in a part 8, quick sort. So we have bonus round part 8, quick sort, and we're going to positive list of integers. So we're going to do a quick sort on positive list of integers on here. There's like so many different ways to do different sortings on this. One of the ways to do it is to look at our list and then partition that list. And then you go through that partition and you sort it, and then you sort a smaller list and a smaller list, and so on and so on. So that's what we're going to do on this one. Before we start though, we do need to go ahead and grab our data and set that up. And so you can do it a number of different ways. We could do comma separated. We're going to switch it up a little bit on this one because it's just fun to try different things. And we're going to do enter in number of objects in the list. We're going to enter each of those values into our array. In our array, we're just going to input an integer of them, print the original list. This should be pretty familiar because we've done so many inputs in this lesson and the last lesson. All we're doing on this one is we're just appending the input here and how many inputs, and so it'll go down the list. And if we go ahead and just run this first piece of code real quick, number of objects in the input, we'll do 3. Values of the objects, we'll do 3, 2, 5. And you can see here's our original series, 3, 2, 5. Pretty basic and straightforward. And because for me space is a commodity as far as our output and the screen I have for your catching you on what you're reading there, we'll just put it on one line. We'll say original list. So the first thing we want to do is if we're going to do partitions, let's create a module for partitioning out our data. And so we'll start with a simple definition, procedure, and we'll call it partition. And we want to take our list that it's sent. We want a low value, a high value. And what we're going to do with this is we're going to create I equals low minus 1. So remember, this is an index, and we actually started with 0, so now we're actually 1 less than the index if we're initiating this with 0 on one end and the maximum on the high end. And we'll call it pivot, and the pivot is going to be a value. We'll set that list equal to our list of our high index. So remember, high and low are indexes. I is an index. Pivot is a value. That's the actual value in this position of whatever we send it. So we're going to send it 2 pointers, low and high, and we're going to send it the list. And when we initiate this, we usually will set it up as a first entity, which is index of 0 for low, and then for high we'll have the highest index on there. Then we need to go ahead and do for j in range, low, comma, high. So we're going to go through all the different values in there, and if list of j is less than or equal to pivot, then I equals I plus 1, but we like to do it the Python way, so plus equals 1. Now remember, we subtracted 1 up here, so this is 1 less than whatever index we sent it, which if we start with 0 would be minus 1. And this brings it back up to 0. So this is why we put this in here at the top part. I'm actually going to stop here just for a second, because sorting is one of the most basic things, but it's very confusing as to why the sorting is so difficult. And one of the reasons it's so difficult is because if I have the numbers 3, 2, 1, there's so many different ways to sort this. One, I could take and look at these two numbers, and if this value is higher than this one, I could swap them, which would then give me 2, 3, 1, and then I can look at these two numbers, and if this is bigger, then I can do swap them, and then I get 2, 1, 3, and then I got to start over because now the 2 and the 1 aren't in order. And so you can see with the lengthy list, whatever I do starts running into factorials, n factorial runs. And there's no real easy way around this, because if I put a reverse list 3, 2, 1, it's going to maximize how many runs it takes. And so finding different ways to sort the data depending on what you're doing can be really confusing. So understanding just what's going on with this particular sort we're doing helps to start understanding where this problem occurs, and certainly there's tools out there to sort it for you which are already maximized. Sometimes you have to sort on values that aren't, the value you're sorting on might be different. It might be, instead of sorting on j, it might be the remainder of j divided by something, or it might be the percentage of j over another column. So being able to sort these things is important, and knowing how this works, the logic behind it, is more important than the actual coding at this point. So we get in here, we go I equals I plus 1. So remember that I put, in this case, we did it somehow reverted there. I plus equals 1. And then we're going to do list of I, comma, list of j equals list of j, comma, list of I. And this is just a cool Python way of swapping values. You can see here we have ji becomes ij. So we're swapping the values up here as we go through this partition on right here. And this works on our counting because we have I, which right off the bat is set to 0. We have high, which is not the end value, but one less than the end value. So our range of j is going from 0 to not quite the last digit. And our I is going from, we've added the plus 1, and then it goes to the end here. So we have our list of I, our list of j, and we swap them out depending on if list of j is greater than pivot. And we can also do something like this. Here's our pivot. We'll just take our pivot out up here. So here we have our list of high is going to be our pivot number that we're switching around, and we're just iterating it through and swapping values. And then finally we'll go ahead and run this one more time. List of I plus 1 of list of high equals list of high, comma, list of I plus 1. So one last swap at the end. Now if you're looking at I equals low minus 1, let's do this. This is kind of fun to do. Clean up our code a little bit. I'm incrementing it right here. Why? I don't know. I can increment it right afterwards, and it has the same result of taking the minus 1 off of here and just adding it after I need it. And this then carries down to here where I have I plus 1. Well, I'm adding it at the end, so I don't need to add it again. And we simplify it down to I equals low. Following our I's through there, we have list of I, list of j, list of j, list of I swapping. Here's our increment, and then our final swap at the end. And what we want to go ahead and do is we just want to return I plus 1. And so if we're going to have our partition set up this way, where we're returning the I plus 1, or in this case just I, we want to return I. Carried it down, forgot to carry it down there. We've taken our list, we've swapped it around because we're passing the list. We're passing the actual list, not just a pointer to it. And then we're going to return the I so we know what we did. And so if you remember down there when I did that example, the first time through we swap it around, and then it comes up and says, oh, okay, we've already swapped the high value all the way up to the right hand side, then we have to start over. So we'll go ahead and call this quick sort. And the quicksort is going to take the list, a low, and a high, just like we did for our partition. And what we want to do that is if low is less than high, then we want to go ahead and partition the index. Let me fix my tabs. There we go. So PT is the value from the partition that's coming back. That's what this I returned. And so we would go ahead and partition our list, and we have our low and high value going in there. If we're going to partition our list, once we get the PT back, we can go ahead and do a quick sort on the same list, low, comma, PT minus 1. So it goes through the list, it moves the highest value to the end, and then we want to take that PT it returns and we want to subtract 1 because we know where the high point is. So now we have a shorter list to go through. And we sort it from the other end too. We'll do a quick sort and we'll do our list, comma, PT plus 1, comma, high. So we're coming out from the other end. So we're basically sorting the list going both directions on here. So this is our sort on this one. We now sorted our list, so we need to go ahead and call that. And we can simply call that, let's see. Oh, we can print out the list. Let's do this. Let's go print. There's our original list, sorted list, and we'll put our little placeholder. Or you know what? We won't put a placeholder there. We'll just put a comma in. And of course, it probably helps to actually return the list. So we'll go up here and do return list that we've nicely sorted on here. And we'll come down here to this part and do quick sort. And we have our list that we put in. We're going to start with 0 for initiating it. And then we have our high value, which is simply the length of the list. Because that points to, it's actually length of the list minus 1. That's going to point to the last index. And then real quick before I run this, let's do some quick cleanup here. The original list, and then we want to create a second list which equals the original, and then we're going to print our sorted list and we're going to send it this information for our quick sort. So let's go ahead and see what that looks like. Let's go ahead and run this, and we're going to enter our number of values. We'll just do 3, and we're going to enter in 3, 2, 1. Let's open this up so we can see what's going on down here. So here's our original list, 3, 2, 1, and you can see it's nicely sorted, 1, 2, 3. And if I was testing this out, I would enter in 1, 2, 3 to see what happened. I would enter in 2, 3, 1. Just some quick changes to make sure it's sorting correctly. In fact, let's go ahead and do that real quick. Let's go ahead and enter another list. We'll do it 4, and I'll do 1, 2, 3, 4. 1, 2, 3, 4 sorts out as 1, 2, 3, 4. And I actually know from doing these so many times that that's more than enough on these. But just in case, let's go 2, 1, 3, 4. And 1, 2, 3, 4. There we go. Quick sort for our list. So that wraps it up. Thank you for joining us today for Python Part 2, where we covered not only 7, but bonus 8 different parts. We went in there and we looked at everything from basically finding the elements in what position on a list, the number of occurrence of characters, to dictionary use and key codes, and finally a quick sort at the end. Again, thank you for joining us. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified. Get ahead. Feel free to comment below on the YouTube video, as we do have moderators who monitor the questions and posts down there, or visit us at our website and we'll be happy to help you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.